What is differential equation? A differential equation is an equation with a function and one or more of its derivatives. What are the use of differential equations? Differential equations have a remarkable ability to predict the world around us. They are used in a wide variety of disciplines from biology, economics, physics, chemistry, and engineering. They can describe exponential growth and decay, the population growth of species, or the change in investment return over time. Why the differential equations are important? The term ordinary is used in contrast with the term partial differential equation, which may be with respect to more than one independent variable. Linear differential equations are the differential equations that are linear in the unknown function and its derivatives. The type of differential equations. An open differential equation, ODE, is the most common type. A limited slip differential overcomes this problem. A locking differential means locker is able to lock the two drive wheels on an axle together. A spool is an open differential in which the axles have been mechanically fastened together. Partial differential equation. Partial differential equations are used to mathematically formulate and thus add the solution of physical and other problems involving functions of several variables such as the propagation of heat or sound, fluid flow, elasticity, electrostatics, electrodynamics. Use of partial differential equations. In mathematics, a partial differential equation is a differential equation that contains beforehand unknown multivariable functions and their partial derivatives. Partial differential equations are used to formulate problems involving functions of several variables and are either solved by hand or used to create a computer model. Order and degree of a differential equation. The order is the highest number derivative in the equation, while the degree is the highest power to which a derivative is raised. For example, y double prime plus y prime is equal to y is first degree second order differential equation. Okay, y double prime plus y prime is equal to y means that the highest derivative is y double prime, so it means order is 2. Order of this differential equation is 2, and since the power exponent of y prime is 1, so this means that its degree is 1. And in y prime square over here we see that y prime square is equal to y means that the derivative is first derivative. The highest derivative is the first derivative, so its order is 1, and since the highest derivative exponent is 2, this is 2, so this means that its degree is 2, so it is second degree first order differential equation. Look at this variety of examples. First of all, dy by dx is equal to 5x plus 6. In this case you can see what is the highest derivative. The highest derivative is dy by dx, so it means order of this over here, it means order is 1, and since its exponent is also 1, so its degree is 1. And in this example you can see that what is the highest derivative? The highest derivative is d square y by dx square, so it means that its order is 2. Order of this differential equation is 2, and you know its exponent is the order of highest derivative. The exponent of highest derivative is since 1, therefore its degree is 1. And in the next example you can see that d cube y by dx cube, the highest derivative is d cube y by dx cube. So since it is third order derivative, and since the exponent of its is 1, so we can say that its degree is 1. So in the next example, dy by dx is equal to 5x plus 6. Since this is first order derivative, this is first order derivative. If it is first order derivative, then it means that order is 1, so its exponent, you can see that its exponent is 2, so its degree is 2. And in the next examples you can see here is the next example. what is the highest derivative? The highest derivative is d square y by dx square. So order is 2, and its exponent of highest derivative is 7. Therefore, its degree is 7. And in the next example, you can see the highest derivative is d cube y by dx cube. So its order is 3, and its exponent since 2, therefore degree is 2. To solve the first order differential equation by separating the variables method, the method is, you can see over here, f of y dy is equal to g of x d of x. What does it mean by? From here you can see in the left hand side is a pure function of y, and the right hand side is the pure function of x. In the separating the variables, what we do, we separate the variables. The variables of x should be in one side, and the variable of y should be on other sides. So this is the example. In this example, you can see x square dy is equal to, this is the example, x square dy is equal to minus x square minus 1 y cube dx. So what we will do, in the left hand side we can see that x square is multiplied by dy, and in the right hand side we can see that minus x square minus 1 y cube, means variables are mixed variables. So we don't need mixed variables. We will separate the variables. X should be in one side and y should be on the other side. So what we will do, since dy, this is dy, and this is y cube, so when we shift y cube on the left hand side, it will of course will come in the denominator, and when we shift this x square on the right hand side, then of course it will take the place in the denominator of the right hand side. Okay, now you can see that on the left hand side the pure function of y, and the right hand side is the pure function of x. When we get this condition, just like left hand side is the pure function of y and the right hand side is the pure function of x, then what we do, we will integrate to find the solution. So integrate on both sides, or taking the integral. You can also write over here taking the integral on both sides. Okay, after taking the integral on both sides, the integration of y raised to the minus 3 is, we add 1 in the exponent and divide by that exponent is the rule of integration. So the derivative of y raised to the minus 3 is y raised to the power minus 2, y raised to the power minus 2 divided by minus 2, and the integration of x raised to the power minus 2 is, we add 1 in the exponent, minus 2 plus 1 here. Okay, the rules of integration you should know. It is minus x raised to the power minus 1, minus 2 plus 1 means x raised to the minus 1 divided by minus 1. Due to that, it is, we get minus sign over here. So the derivative of minus 1 is minus x, and this is constant of integration. And after multiplying by minus, so after multiplying by minus, it will be positive, it will be positive, it will be positive, and it will be positive. Other term will be positive. So this is our solution by separating the variables. What is homogeneous differential equation? A linear differential equation is homogeneous if it is homogeneous linear equation in the unknown function and its derivatives. In this example, you can see that on the right hand side, dy by dx is equal to x square plus xy divided by y square divided by x square. Here you can see that in the denominator there are 3 terms, x square plus xy plus y square, and the degree of each term is 2, and the degree of each term in the denominator is also 2. Here the degree is 2, and in xy the degree is also 2, because x plus the exponent of x is 1 and the exponent of y is 1, so 1 plus 1 is equal to 2. And here also y plus y square means degree is 2, means the degree of each term in the numerator and denominator both, degree of each term is same. Since the degree of each term is same, therefore it is homogeneous equation, because in homogeneous equation the degree of each term is same. So next, so what is the method? How we solve the homogeneous differential equation? The method is, we put y is equal to v of x, y is equal to v of x, and when we take the derivative of y, it will be dy by dx, and when we take the derivative of y vx, so what is the derivative of vx? By the product rule, the v first as it is, and derivative of x is 1, plus x as it is, and the derivative of v is dv over dx. Therefore we can write dy by dx, or we can put this value. Suppose this is equation 1 and this is equation 1. Okay, put in equation 1 y is equal to vx in equation 1, and y is equal to vx, and what is dy by dx? It is dy by dx is equal to this one, so this will be equal to this one, means by putting over here we get this. So x square is just like s, and the value of again x y is equal to vx, it will be vx square, and y is equal to vx mean v square x square divided by x square, and we can see over here x square is common in the denominator, and so that x square will be cancelled and we get this one. Okay, and after that, in the left hand side is v plus x, v, and this v will be cancelled out and we get these equations. Now what we will do, by separating the variables, 1 plus v square, when 1 plus v square shift in the left hand side, it will be in the denominator, and when we shift x in the right hand side, it will be also in the denominator. Now integrating both sides, after integrating on both sides, what we will get? We get the derivative by integrating. It is just like integrating, the integration of 1 plus v square is tan inverse v, it will be tan inverse v, and the integration of x is natural log of x. Now we put the value of v. What is the value of v? Since y is equal to vx, and from here y is equal to vx, from here v is equal to y over x, v is equal to y over x. Okay, now putting here tan inverse v means that it is y over x, and this is our solution. By which method? By homogeneous differential equation. How to solve the homogeneous differential equation? What is non-homogeneous differential equation? Recall that second order linear differential equation with the constant coefficient have the form a double prime b y prime plus c y is equal to g of x. Now we will solve equations where g of x is not equal to 0, which are non-homogeneous differential equation. So any differential equations of the form, this form is non-homogeneous differential equation. A first order differential equation of the form a1 of x dy by dx plus a0 of x y is equal to g of x is said to be linear differential equations in the dependent variable y, and if g of x is equal to 0, then it is homogeneous differential equations, and if g of x is not equal to 0, then it is non-homogeneous differential equation. Whatsoever, this is the linear equation a1 of x, so here will be x multiply dy by dx is multiplied by function of x, and here will also be function of x with multiply by y, and the right hand side will be the pure function of x. If it is the form, then it is linear differential equation. Now we see the difference between second order linear and non-linear differential equation. So the general form of linear and non-linear differential equation is y double prime plus f of x y prime plus g of x y is equal to r of x. So here we can see y double prime means here maybe any kind of constant, and this is f of x, g of x, and r of x. So in case of f of x, it may be there is any constant, and in g of x it may be g of x or any other constant, and in case of r of x it may be any constant or r of x. So the example of linear equation is y double prime plus xy prime plus x square y is equal to e raised to the minus x, and the second example is y double prime plus cy is equal to 0. So here we discuss why it is linear, and first we see the example of non-linear, which is y double prime y plus y prime plus xy is equal to 0. Of course it is linear. y double prime minus y prime plus 1 is equal to 0. So why these two equations are non-linear and why the first two equations are linear? Here you can see when y is multiplied, here you can see y is multiplied by y double prime. Then if we see here, x is multiplied by y prime. If y is multiplied by y prime or x is multiplied by if x is multiplied by y prime, then it is linear, and if y is multiplied by y double prime, then it is non-linear. And since this is in surd form, if it is in surd form, then of course it is non-linear. And equations of differential equations which is in surd form is non-linear. But these differential equations, why it is non-linear? Because y is multiplied by y double prime. Okay, y is multiplied by y double prime. Due to this reasons it is non-linear. And suppose if I say y is multiplied by y, it is again non-linear. It is not linear now. Exact differential equation. Exact and inexact differential are specially used in thermodynamics to express if a partial differential equation is dependent on path or not. Exact differential equation represent the given function is independent of path. They depend upon their initial and final state, and therefore they are called state or point function. Exact differential equation. If m and n are functions of x and y, then partial m divided by partial y is equal to partial n divided by partial x. If this condition is satisfied, then it means that the given differential equation is an exact differential equation. And if the differential equation is an exact differential equation, then its solution will be m into dx plus n into dy plus n into dy is equal to c. Now you can see this example, 3x square minus 2y square plus 1 minus 4xy y prime is equal to 0. Here you can see 3x square minus 2y square. This is m, okay, and 1 minus 4xy, this is y, because we convert first y prime is equal to dy by dx, so it is m. If we take the partial derivative of m with respect to x, it will be partial m with respect to y, partial derivative of m with respect to y, it will be partial derivative. If we are taking the partial derivative with respect to this is constant, and the partial derivative of 2y square is minus 2y square is minus 4y, and if we are taking the derivative here 1 minus 4xy with respect to x, and the derivative of 1 will be 0, and the derivative of minus 4xy is minus 4y. Therefore partial m divided by partial y, derivative of m with respect to y and derivative of n with respect to x are same. Therefore the given differential equation, this differential equation is an exact differential equation. Integrating factor of first order differential equation of the form p of xy dx plus q of xy dy is equal to 0 is not exact, but it will be exact. Suppose if it is not exact, and it will be exact if we multiply a function, and what is that function may be the function of x and maybe the function of y. After multiplying by this function f of xy, the given differential equation will be exact differential equation after multiplying the integrating factor. Actually we find the integrating factor for what purpose? Only for one purpose. We want to make the differential equation exact. A differential equation which is looking non-exact, what we do, we multiply the integrating factor to make that differential equation exact. So suppose if this differential equation is non-exact, this differential equation is not exact, then what we will do, we will multiply by integrating factor. After multiplying the integrating factor will be a function. What kind of function? It will be f of xy like function. After multiplying these functions, this differential equation will get exact, and if it is exact, then it is easy to find the solution of differential equations, maybe by the homogeneous method or by the separating the variables. How to make a first order differential equation exact differential equation? By finding the integrating factor. So in this example, xy square plus 4x square y into dx plus 3x square y plus 4x cube and into dy is equal to 0. Of course this is equal to m and this is n. In this case, if we take the partial derivative of m with respect to y, then what will be the answer? Partial derivative of m with respect to y, it will be 2xy and plus 4x square. And what is the here, if we see partial derivative of n with respect to x, what will be the partial derivative of n with respect to x? It will be 6xy plus 12x square. So this means that partial derivative of m with respect to y and partial derivative of n with respect to x are not same. So it means that this is not exact. We want to make it exact. What we will do, we will find the integrating factor. There is a special method so how to find the integrating factors. There are 4 different methods to find the integrating factors. I have discussed in the next lectures. There are a brief descriptions in this course how to find the integrating factors. In the next lectures you will understand how to find the integrating factors, but here just for the short descriptions, for the short review of the course, I am just telling you, if I find the integrating factor, suppose the integrating factor is y over x, we will multiply the integrating factors. After multiplying the integrating factors, this differential equation will be exact, means partial derivative of m with respect to y and partial derivative of n with respect to x will be same. So it means that this is exact. If this is exact, and you know how to find the solution of exact differential equations as we are discussed in the last lecture.